Welcome back everyone, and in today's video we're going to explore infinite terrains. We've done terrains in the past, and usually we would just create chunks of terrains and we can just lay them next to each other. Today we're going to build a tool or a management tool or whatever object that will actually help us manage those chunks in a smart way. And not only do we just manage those chunks, we're also going to recycle them. So this way we only create a certain amount of terrain pieces, and those terrain pieces will then get reused over and over again, and just maybe get the vertices updated to create new terrain. So we're going to divide the world up into a grid, and the grid is basically going to be what size of whatever our terrain chunks are. But we're going to create only like 9 pieces at a time. And the centerpiece is technically where the main camera is going to be. And I don't know what this object is. And can I get rid of this? Yeah, there we go. And our main object or a camera or a character is always going to exist at the center of this managed area. So the center of this managed area is going to have like a coordinate system of 0, 0. So it's kind of like X and Y type of system. And up here is going to be like 0, -1, because in the Z plane everything goes negative. So this is X and this is Z. So that's kind of how our world coordinate system works anyway in WebGL. And yeah, and this is basically will be our coordinate system. Will be just 1, 0, -1, 0, and that's that's going to be our grid system. And when we move over, so let's say we move over to, let's say we were in a centerpiece and then we move over here. This becomes -1 and 0. This one now becomes -2 and 0. This one becomes 0 and 0. Everything just shifts over, and that's going to be it. And basically, these 6 columns get shifted over. Those pieces get shifted over, and then these pieces that are no longer being visible get thrown over here, and then get updated. And that's going to be our management system for terrain chunks to create infinite terrains. And we're going to build a reusable object. So this way, it's just not tied to terrains. It can be anything. It could be anything that we want to do this type of functionality with. So we're going to look at some code, and we're going to start off pretty simply. There's nothing we're going to import that's anything special. We're going to import noise, so this way we can kind of do some fun stuff. And I'm not going to do terrains in this one. The terrain is going to be later. Right now we're just going to use quads to create our area. And we got some global variables, P9 and Q VAO. I don't know why. Why is it called Q? I don't know. But P9 is going to be short for the new object that I have called patch 9. Because like I said, we're making a patch of 9 objects. Over here, we're going to have some event handling. We're going to check the keyboard. And if you press mouse up, down, left, or right, you'll move in those directions. You'll just move in the directions and say update areas. And that function will actually just recalculate everything, kind of just move all the pieces to where they need to be. Wherever objects that don't need to be recycled get moved, anything gets recycled gets moved into its new place, and its data updated. Okay, so Q is our quad VAO. So I'm going to make one VAO for a quad, and I'm going to just reuse that for all our things. So there you go. And I'm going to use a function called section for now. So let's really look at our patch 9 first. So patch 9 object is supposed to be managing essentially all our chunks. So when we start off with, we have a unit size and a recycle handler. So every time we do an update to a piece, that's no longer visible, we need to recycle it. So we can actually pass in a pointer to a function or a reference to a function that handles that recycling. So this way, the recycling is not built into patch 9. You kind of add that functionality to it. That's why when I said I want to make this reusable, that means any object can be updated. So we can use patch 9 for anything that wants to, in any kind of components really, that we want to manage in that grid or that world grid type of system. So we build our 9 areas. We defined its coordinate system, where it exists currently in its coordinates, and then the index to the pool. So right now, these sections, these areas in our patch 9 have nothing, but these are the default coordinate systems. Then we have our pool object, which also has the coordinate system, and this is where we're going to hold our transforms. So the idea is we're going to have like we need to kind of 2 different lists, because we need one list that's currently active and kind of one list that we can finagle with and then update. So areas is where everything exists currently in the world, and pool is our actual transforms that we're managing, and we're going to change them up and around, and we got to shift them around, and the order of this does not matter. Absolutely does not matter. The order, like the X and Y's will change, but the X and Y in the areas will always be based on the center being the origin. So the order will. So let's see. The 5th element will always be the center. This will always be the right side. This would be the left side, and so on. This would be the top. This is the bottom. In the areas, they will always stay there, and this will always be the center. And our pool is, like I said, it's just it holds all the transforms that we're going to use, and that's where this function comes in. Add transform. So you add a transform. It searches the pool. It finds an item that an area that's currently not being used. It sets it as the item, and then it calls the recycle handler on it. So the recycle handler passes in its coordinate system, and then the actual object that's being moved or it needs to be refreshed. So this way we can make it easier to manage this dynamically. So that's what add transform does. Move basically just moves it based on our current position. So area X and area Y tells our current location currently, which is where's the center. So the center is at 0, 0, and eventually if we want to move somewhere, we change this, and then based on this value, all these get recalculated with this array element being the center of the 9 patch, the patch 9. So by moving it, we just say how many on X and how many Y we want to move from the center, and then we just add it to where our currently place is, and we call the center function. And the center function we can also call and give it a specific location. So let's say if you're loading a game and you want to start the character at a certain area, you wouldn't say go to move. You would just say center, X and Y, like 10, 15. That's the area you're currently in, and it'll just recalculate. So this kind of move feeds into center, and this ends up just recalculating the whole array. It's like there's not really much to it. It's just simple math, really. I don't want to go too crazy into it. When you're done moving everything, then you got to call your update function. We define the ranges, so this way we can actually find out which elements that needs to recycle. So these are the ranges that currently exists in the patch 9. So what's the like basically a bounding box? What's the minimum and maximum with minimum and maximum X and Y position? That's what this is really going on. And based on that, I can then say if this item is not within this boundary, that means that item is no longer that's viewable. So I'm going to push this to the recycling bin because I need to recycle this item. If this item is within the boundary, I got to go find where it used to be in the areas and then update the information and just add the new index. So like if one of these items is not being recycled, they just need to be moved. I just search the area where it used to be and change the index value to where to what it should be. When it's all said and done, when it's all nice and updated, we go through the list, our stack of recycled items, and we just search the areas for a good place to put it. We set its new position because it's a transform. So the only thing this thing handles is the positioning in the world space. Other than that, everything else has to be handled externally from the recycle handler. So patch 9 only handles position for a transform, and it moves it to exactly where it needs to go. It's based on unit size, and I have hard-coded a value here just so to make certain things work. But this should be actually 0. And unit size, and like I said, it handles recycler. And I have a little debug function in here just so I can output and see the grid if I want to. And last but not least, just a throwaway object that I created to use instead of a terrain object. So this, all it does is take that global quad, makes a renderable out of it, and has an update function that actually, based on the X and Y position of that world, it uses it to create uses Perlin noise to pick a color. So this way, if I move away and move back, I always get that color. So it's kind of like doing terrains with noise. When I move away from it and come back, I want the terrain always to be the exact same. So instead of me using a random, which makes it hard for me to tell if I'm moving correctly, I'm using noise to actually choose the color of my quad. And that's pretty much it. And the recycle function that I pass in, it just tells it that item that item, call its update color function, and that's where that noise is. And that is pretty much the patch 9. So if I go to patch 9, this is what the output of the page is. It's a quad. Like I said, there's 9 quads, and this quad is at 0, 0. So if I use the mouse keyboard, I can move. And if you look where the mouse is, it's always that gray color. So I can go away, come back. It's always that gray color. Same thing with, let's say, this blue color. If I keep the mouse on it, just focus on that position. I walk away, and there's the exact same color because I'm using noise. And this is exactly what we want. Now, the patches are actually really small, but in real world, you can define the unit size. Let's see, patch 9, quad size. So right now I set it for 1.5. If I want to, I can set it for 3. And now the patches are huge, are bigger. And the colors are the same for the most part, because I'm still using the same XY coordinate system, even though the area is a lot bigger. And that's it. And that's really how you can create infinite terrains. And I really like that this is a reusable object because I'm not using a terrain object. I'm using just quads. So this object can be reused for anything really. It doesn't have to be terrains. Or you can swap out new different type of terrain functions or objects and whatever. So it really makes things a lot easier when it's when you create objects that's more modular. And then I have my infinite thing, and it's same thing, but now it's using our terrain chunks object, and that's what our terrain looks like. And if I were to move, it's the same thing. Now the only difference is it's updating the terrains instead of updating the quads. So just think about it. If I was zoomed in and I had a character living it, and the character slowly moving through the world, and so that's the part where I don't have built yet, but all the functionality is there. So when the world, you just need something that monitors the world and compared to the user. And if the user, it no longer is in the center point, it's like, let's say, one of the other quads, you automatically shift that area as the center, and then you kind of just fill in the rest, just like this. So all the functionality is there. All we just have to do is move it, because right now, I have control over it manually. And I just moved everything over to its own file now, so it's reusable. All the same, everything is the same thing. I left that as 0. It should be 0. This is a terrain grid. It creates the grid for terrains. Here's a terrain chunk. Very easy. Nothing much to it. I don't think I create a function, special. I have a function here called chunk noise that just kind of uses all different. We've done this in the past. I probably just fixed this up a little bit and added it here for this page alone. Yeah, like I said, there's not much to it. I'm just reusing chunk noise. Okay, because I think chunk noise makes a single grid, modifies the grid, and then pushes that grid to that specific VAO. And so this way, I only have one piece of data only one grid of data I'm using. So I end up just reusing the exact same data. So instead of each chunk having its own set of vertices, I only have one set of vertices that I update, and all I have to do is update the Y position. So change offset, all it does is ends up doing the Perlin noise, and all it does is update the Y position. If I plus 1 is X, Y, Z, so plus 1 is for the Y. So I'm just changing the Y vertice at every point, every time I move it. So that's what this function does. So I've done, like I said, I've done terrains a lot before, and just a new spin on it just to get infinite terrains. And like I said, and this is the recycle handler. You pass in the item, I tell it, to change its offset, and then that chunk, I tell it to update the buffers, and I pass in the vertice array, and it just updates it. So, and yeah, that's it. And this creates the chunks, creates the dynamic chunk, adds it to the scene, and it adds it as a transform for the patch 9. And loop. And that's it. And like I said, there's a lot of stuff we've done in the past. It's not a lot of code. In all honesty, if you think about it, I have just terrain. All the code is actually pretty minimal, and the patch 9 is not that bad either. It's pretty minimal. And can I easily update unit size? I think so. Can I say 4? Can I make the terrains even bigger? Yeah, I can make the terrains even bigger. Terrain noise, cell count. Let's make this 16. So this way I can probably even make bigger. More detailed? No, not more detailed. Height is 1. Let's do 32. See if I can make the terrain. There you go. Yeah, like I said, you can play around with it. Probably because I made it too big. If I make it like a 2, maybe it'll look better. Oh, more rocky. More of a mountainy area. But like I said, you can play around with noise. The frequency is probably too high. Probably need to change the frequency to something smaller, maybe. Yeah, there we go. That's a little better. And then, why not? Let's make these really high. Try to make them high resolution. I guess you always got to play around with the frequency. Let's go back to 32. I'm probably wasting too much time with this because there's no point. Refresh. Because this is just playing with noise. 0.5. Let's do the frequency a little. Oh, that's better. That's kind of like, this is what I was kind of trying to go for. More of a sand duney kind of look. So this way I can pretend that you're walking through like the desert. So there's more sand dune-ish, and it has more vertice count, so it's a little higher quality meshes that are being generated. And the more you generate, the higher the resolution the more it takes to render. So this kind of system kind of needs to be kind of added to like maybe like a threading thing. So when you're recycling your vertices, they go into like a thread or a worker thread or whatever, and then one or two frames later, when it's done generating, then you actually update the GPU and then actually display the data correctly. So this is a kind of a bare bones infinite, but like there's more optimization that should be done in the future if you're gonna build this. But yeah, there you go, infinite terrains. And like I said, and it's a reusable object, so you can use anything. Like I said, before I was using quads, now I'm using terrain chunks. It's very customizable and it's very minimal. And that's it. That's so yeah, that's infinite terrains. That's it for this. For the next 6 videos, we're going to be building the ECS system. So we're going to build a brand new system, and it's going to make our application super flexible and much more easier to prototype in the future, because we do a lot of prototyping, and the entity component system will actually make things easier. And it's exactly what a lot of big game engines use or are going to use. So that's what we're going to be doing in the next couple of videos. So if you don't like that, just skip the next 6 videos and whatever. So please like and subscribe. Thank you for all my Patreons. Like I said, I'm unemployed at the moment, and every little dollar helps. So thanks for watching. Hope you learned something. Everything's on GitHub, so you can actually go download it, play with it, use it. I don't care. Licensing is completely free. I don't care. Just use it. It's open source. Have fun with it. And I'll see you guys in the next video.